Hello guys, so welcome to Mechanical Bars. Today we will practice or we will go into the depth of number system. Okay, because number system plays a very important role in mathematics. So we have to be good in number system. Okay, so that we can uh, doesn't matter. So this is a part of engineering mathematics. Okay, so let's start with number system. So now, okay, here we will read some theories. Okay, we will read some theories. In this section, we see some elementary properties of divisibility of integers. Divisibility of integers. In this section, we see some elementary properties of integer. The reader is familiar with properties of integers such as divisibility, greatest common divisor, okay, highest common factor, least common multiple, the prime and composite number. In this chapter, we will give definition and then proofs of the properties which reader quite often has used without proof. Many of the proofs depend on two principles. First, well ordering principle. Second, principle of mathematical induction. Okay, we first state these two principles. Well ordering principle. Okay, so these are the two principles on which we can solve the number theory chapters problems. Okay, so first well ordering principle, second principle of mathematical induction. Okay, any non-empty subset of non-negative integer has the smallest element. In other words, if S is a non-empty subset of non-negative integers, then there is a S, okay, such that A less than equals to S for any S in S. Okay, principle of mathematical induction is a logical consequence of the well ordering principle. Principle of mathematical induction is a logical consequence of the well ordering principle. Okay, principle of mathematical induction. If a subset S of positive integers contains 1 and contains n plus 1, whenever it contains n, then S contains all the positive integers. Principle of mathematical induction strong form. If a subset S of positive integers contains 1 and contains n plus 1, whenever it contains 1, 2, dot 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 n, then S contains all the positive integers. Okay, then S contains all the positive integers. Okay. Okay, so we will solve theorem of number systems one by one. Okay, so the theorem 1. Theorem 1, let A, B, C, N, X, Y be integers. Okay, then if A by B, then A by BC for any integer, for any integer C. Okay, if A by B, then A by BC for any integer C. So we have to first solve this theorem. Okay, then we will move the proof. They are saying that if A by B, okay, then B by B is equal to AQ. B is equal to AQ, where Q is an integer. Okay, where Q is an integer, hence BC is equal to A into QC for any integer, hence A by BC. Hence A by BC. So now this is the total theorem and its proof. Okay, if A by B, then A by BC for any integer CH. If A by B, then A by BC for any integer C. Okay, then the proof is if A by B, then B is equal to AQ, where Q is an integer. Hence BC is equal to A into QC. BC is equal to A into QC. BC is equal to A into QC for any integer. Okay, hence A upon BC. If A by B, then B is equal to AQ, then B is equal to AQ, where Q is an integer, hence B is equal to A into QC. A into QC for any integer, hence A upon BC. They say where Q is an integer. Okay, so Q is an integer. Now, hence BC is equal to A into QC for any integer, hence A upon BC. Now, what we have to do? B is equal to A upon AQ. B is equal to A upon AQ, where Q is an integer, hence BC is equal to A into QC. BC is equal to A into QC for any integer, hence A upon BC. For any integers. Okay, suppose, okay, so this is done. Actually, this is done. So, have you guys noted it? Note it down. Pause the video and note it down. Then we will solve, or we will understand the meaning of this proof. Okay, then we will understand the meaning of this proof. Pause the video and note it down. Okay, done? Okay. I'm removing this, and I am writing the proof. Okay, I think I don't have to write the proof. Already you guys have noted it. Okay, so I won't write the proof. I will directly move to the solving part or understanding part. Okay. So here they said proof. Okay, A by B is equal to Q. Okay, here Q is an integer, we all know. Now B is equal to AQ. B is equal to AQ. Okay, B is equal to A by B is equal to Q, then B is equal to AQ. Hence BC is equal to B is equal to AQ, A into QC. Okay, so here therefore B is equal to AQ. B is equal to AQ. Okay. B is equal to AQ for any integer C. For any integer C. For any integer C. Hence, so for any integer C, so they are also taking an integer C, like they are multiplying BC. So the AQ, suppose so AQ into C. Okay, like this. Okay, AQ into C. So this becomes BC into Q for any integer C. This is also they are taking an integer C. Okay, now this become Q. Q is equal to BC by BC by AC. Sorry. Okay, so they are just taken. Okay, here we will write two things. Okay, suppose here this one. Okay, like this one, and the second one is integer C. Okay, integer C. Now we have written this, and Q is equal to BC by A. BC by A. BC by A. So this is a kind of proof, theorem and its proof. Okay. When we will see its application, then we will actually understand what its actual meaning. Okay, then we will understand its actual meaning. Okay, so let's move to the next part. Okay, I am erasing this. Okay, let's move to the next part of this theorem 2 of this theorem, I think. Subsets. Okay, here they are saying theorem. This is okay. We are all doing theorem 1, right? Theorem 1 and its subset. Okay, so second number subset. Okay, if A by B and B by C, then A by C. Okay, if A by B and B by C, then it is A by C. Okay, so now we have to prove it. Okay, now what we have to do? Okay, so now let's try to prove this theorem. Okay, we will solve this. Okay, we will try to solve this. If it doesn't, then we will the solution B by C. Then it is saying A. Then it is saying. Then it is saying A by C. How? Okay, why we will take? Suppose this happens. If we multiply. Okay, this is very stupid idea I am telling you to prove this. Multiply. Suppose we multiply it. Okay, we multiply it. A by B, B by C. Okay, B multiplied. Now A by C. A by C. Okay, and now this A by C comes. This is proved. Okay, proved. Or we can do something. We can take something like A by B. A by B is equal to B by C. No. No, this will not happen. Suppose we divide B by A by B, B by C. Okay? This become A by then AC by no, this will not happen. Okay, this is one pattern by we can prove that A by B and B by C, then it is A by C. This is one pattern. Okay. Now oh yeah, so they are just taking integers and they are doing the same one. They are just taking the integers. Okay, they are doing otherwise nothing. They are just taking the integers. Okay, so here if A by B and B by C, then B is equal to AQ, B is equal to AQ, C is equal to BQ1, where Q and Q1, where Q and Q1 are integers. Where Q and Q1, where Q and Q1 are integers. Okay. So then, no, thus C is equal to AQ into Q1, AQ into Q1 is equal to A into Q into Q1, A into Q into Q1, hence A by C dot, hence A by C dot, okay? So this is a proof of this theorem. This is a proof of this theorem. This is a proof of this theorem. Okay, now, okay guys, is this visible? Is my writings visible? Okay, visible. Here they are saying, okay guys, note it down first. Note it down first, then we will solve it. Okay guys, done. Now, if A by B, if A by B and B by C, then B is equal to AQ. Okay, again they are taking an integer. C is equal to BQ1, while Q and Q1 are integers. Thus, C into Q. Okay guys, now I hope you guys got it. Now I'm erasing this. Then I will write the proof in the next part. Here, guys. Okay, so here we see that B is equal to AQ. B is equal to AQ. C is equal to AQ1, where Q1 integer. Okay, thus C is equal to AQ into Q1. AQ into Q1 is equal to A into Q into Q1. Okay, hence A by C. Now, okay. So here AQ. C is equal to AQ. BQ1. Okay guys, let me think. Okay, let me think, then we will solve it. Okay guys, this is very easy. Okay. This is very easy. Here B is equal to AQ, C is equal to B into Q1. Okay. So in this manner we can write. C is equal to BAQ. Okay. That means AQ. C is equal to what? B into Q1. So and B is equal to what? AQ. Okay. So we can write AQ into Q1. Okay. Now if we do, suppose C is equal to A into Q into Q1. A into Q into Q1. Okay. Okay. So this is the writing. Now okay. Now in this manner, if we take Q into Q1 is equal to C by A. So this is coming C by A. C by A. In this manner, this is coming C by A. So is this the process